While they definitely have their differences, some of the approaches used on traditional data can also be implemented on big data. Collecting and pre-processing big data is essential to help organize the data before doing analyses or making predictions, as is grouping the data into classes or categories. While working with big data, things can get a little more complex. You have much more variety. Beyond the simple distinction of numerical and categorical data, examples of big data can be text data, digital image data, digital video data, digital audio data, and more. Consequently, with a larger amount of data types comes a wider range of data cleansing methods. There are techniques that verify that a digital image observation is ready for processing, and specific approaches exist that can ensure the audio quality of your file is adequate to proceed. So, what about dealing with missing values? This step is a crucial one, as big data has big missing values, which is a big problem. To exemplify, let's take a look at some case-specific techniques for dealing with big data. Text data mining represents the process of deriving valuable, unstructured data from a text. Let's elaborate. Think of the huge amount of text that is stored in digital format. Well, there are many scientific projects in progress which aim to extract specific text information from digital sources. For instance, you may have a database which has stored information from academic papers about marketing expenditure, the main topic of your research. You could find the information you need without much of a problem if the number of sources and the volume of text stored in your database was low enough. Often, though the data is huge, it may contain information from academic papers, blog articles, online platforms, private Excel files, and more. This means you will need to extract marketing expenditure information from many sources. In other words, big data. Not an easy task, which has led to academics and practitioners developing methods to perform text data mining. Cool. What else? Data masking. If you want to maintain a credible business or governmental activity, you must preserve confidential information. However, when personal information is shared online, it doesn't mean that it can't be touched or used for analysis. Instead, you must apply some data masking techniques so you can analyze the information without compromising private details. Like data shuffling, data masking can be quite complex. It conceals the original data with random and false data, allowing you to conduct analysis and keep all confidential information in a secure place. An example of applying data masking to big data is through what we called confidentiality-preserving data mining techniques. Nice! To conclude the lecture, look at this graph. It is a simplified version of what big data teams are constantly dealing with. In contrast to traditional data visualizations, the objects do not represent data tables and their interrelationships. Rather, they show the complex way in which data is derived from many sources. Basically, whenever you see a large number of lines intersecting, most probably you are looking at a visualization about big data. Even without examining the graph thoroughly, you can appreciate how much harder it is to make sense of big data compared to traditional data. Okay, we hope you got the gist of the steps you must follow when working with data, whether traditional or big. Once you are done with data processing and you have obtained the valuable and meaningful information you need, you can begin the analysis of your data. And that's the topic of our next video. See you there!